about what if analysis for linear programming. Well, there are many objectives to accomplish, but only part of this um, will be accomplished today because I am discussing only half of this presentation. So today, I only want you to be able to understand what if analysis and sensitivity analysis, which is a kind of what if analysis. You should be also able to enumerate what changes can be done on the LP model when we do the sensitivity analysis. Another objective should be for you to understand or interpret a parameter analysis report and also the sensitivity report for the allowable range. And finally, you should be able to understand how to conduct the sensitivity analysis, what's the procedure, and also how to understand or interpret the reports. Having conducted the sensitivity analysis, so just part now of this long list of objectives. Well, the use of what if analysis is to aid or help the managers or the top management guys make better decisions. And as we already know, no, in what if analysis and also in real life, no, when we say what if, we're actually trying to um, put ourselves in certain situations in the future. So we're trying to paint, no, or visualize some probabilities that may occur in the future in order for us to come up with ready options. Okay, some choices that we can uh, execute, no, when such probabilities may occur in the future. Um, which means to say that we are better prepared to prepare for anything, no, any possibilities that may occur in the future makes us better prepared and we're able to react better, no, when we have prepared for certain contingencies. Now, here, um, we'll be discussing what if analysis within the context of quantitative analysis, no, in management, or as it applies, no, what if analysis as it applies in quantitative um, managerial decision making. Okay, so why conduct what if analysis, or what is the importance of this? Well, what if analysis is relevant in an environment, in a business environment that is replete with changes. There are many changes occurring every now and then in the business world, and some of these changes are here in enumerated, such as there could be changes in costs, prices, market conditions, and also in the data that inaccuracies may occur. Well, the first three here in the list, cost, prices, and market conditions, um, they are more likely to occur in the environment external to the firm, like the cost of raw materials, labor costs, logistical costs, advertising costs. So these are some of the costs that really change from time to time. And the prices are affected by these costs. Now, the profit as well, no, which is part of the price, will also change. So that for every given change in cost, it is bound to affect the profit. And for every change also in the prices, no, of the inputs, it's also bound to affect the profit of the firm. Now, the market conditions, which refer to the uh, supply and demand uh, conditions, are bound to affect also prices and costs. So these three factors here are really interrelated. Now, the inaccuracies, on the other hand, will stem from the data that we procure, no, or that the management scientist would get from the, let's say, operations department. So the data, no, that we get from, let's say, the operations department may only be accurate on the day it was gathered, because as we have said, there are changes on a day-to-day basis that the data we have gathered, like let's say prices or the profit computed, no, may no longer be that exact, that exact amount, because the data would change on a day-to-day basis. But then why still use this data if it is not that exact? It's not applicable um, so much. But well, for decision making and for a study, we have to have a basis, and we cannot have any basis at all without these estimates. So we really have need for these estimates. At least we have a basis, no, for our analysis, for our sensitivity analysis. At least there is a basis from which we could start rather than having no data at all. All right. Well, the focus of this sensitivity analysis, and by the way, sensitivity analysis is a kind of what if analysis. And that is the kind of analysis we are going to discuss today. Okay, here we are given two scenarios. What happens? The first scenario is what happens to the optimal solution if conditions change in the future. And another one is what happens also to the optimal solution if managerial policy decisions change. Okay, the first question here is about changes in the environment of the firm, no, in the external environment. And then the second question is about changes within the organization. And this is the one, no, that is more relevant to our discussion. The internal changes, no, like policy changes, the manager policy may change. The aspects, no, what which are within the policies of managers. No, we are given here some examples like change in production time, levels of output, and the availability of resources. For example, the production time or the machine time or the man hours available, that is within the decision of management. Let us say that operating hours were shortened. Okay, it acts as a constraint. So these are constraints, no? Um, in this case, the policy decisions, no, the managerial decisions would impact certain constraints, no, like those pertaining to the availability of resources, the shortening or lengthening of the production time, the increase or decrease in the output level. These are all affected, no, by managers' policies, managerial policies. And any of these changes will affect or will have an effect on the optimal solution. That's what we want to see, no? For example, if changing the production time, let's say lessening the production time, what will be the impact on the optimal solution? Will it change? And then another example is if the resources available were lessened because of managers' decision to cut costs, which will impact the availability of resources. What will be the impact on our optimal solution? And a more concrete example is in our previous calculation of uh, how many cupcakes to produce in combination with how many enzymadas to produce, we came up with an optimal solution, which is combination of 400 enzymadas and 1,000 cupcakes. So that was our optimal solution. Now, what will happen to that solution if we change the unit profit? No? If we either increase or decrease any of the unit profit for enzymadas or for the cupcakes. Um, but that unit profit is affected by external conditions. Now, within the internal environment of the firm, the optimal solution of 400 and 1,000 combination, no, of units to produce of enzymadas and cupcakes, that will be affected or may be affected by a change in the resources available, like the availability or the amount available of flour. No? How much flour is available, how many kilos, no, are available, or another constraint like the amount of sugar available. If any of these resources or raw materials were lessened, we want to see if there will be an effect on the optimal solution of 400 and 1,000 units to produce. So that's exactly what we want to find out. If there will be any change in the optimal solution for a given change in any of these numbers. And these numbers are actually what we call parameters. Okay. Uh, so aside from the word sensitivity analysis, okay, which is herein already given, no, what sensitivity analysis is, uh, finding out how sensitive optimal solution is to the value of each parameter. There you see it, no? The other word that we want to understand is parameter. Before you should be able to understand sensitivity analysis, you first have to understand parameter. Okay, now what is a parameter? Before we even be able to understand sensitive parameters, let us first understand parameters. We have two kinds of parameters being considered here. First is the coefficients. That's a kind of parameter. Coefficients in the objective function. The other parameters are found in the right-hand sides of the functional constraints. When we say right-hand side, it's at the right hand, the right side of these inequality signs or even equal signs. Okay. Now, for you to better understand these parameters, let's have the spreadsheet first. Okay. So we use a spreadsheet to conduct the sensitivity analysis. But let us first understand what a parameter is. The first group of parameters are the coefficients, the numerical coefficients in the objective function. The objective function is actually located here in cell G12. We have the total profit. Embedded here, you're able to see here only the total profit. But we want to know the algebraic equation beneath this, no? What is the formula beneath this total profit? The formula is given as sum product, okay, equals sum product of unit profit and units produced. In the units produced, uh, the D and the W are the variables. When the optimal solution 2 and 6 are unknown, we have 0 here, 0 here. It means that we have unknown number of doors and windows. So that makes D for our symbol doors and W for windows as variables. So we have D and W variables. Okay. Can we also call this X and Y? Sure. Or even X sub 1 and X sub 2. So we have those D or X for our unknown variables yan. Now the parameters are the $300 and the $500. These are the coefficients and they are constants. Therefore, the constants of the objective function here are actually the parameters being referred to. Okay, so we have $300 and $500 as the parameters in this model. Parameters in the objective coefficients. Parameters in the objective function. The parameters here is this coefficient 300 and the coefficient 500. Ulitin ko, no? The algebraic equation is expressed as 300 times D plus 500 times W. So we have the coefficients 300 and 500 as our parameters on this model. Now, the other kind of parameters are located, as I have mentioned earlier, in the right-hand side of the functional constraints. The functional constraints are here, this one, no? We have hours used less than or equal to hours available. Therefore, we have two sides of the constraints, the functional constraints. We have the left-hand side, hours used, 2, 12, and 18. And we have the right-hand side, hours available, 4, 12, and 18. Which of these are being referred to as the parameters? Those in the right hand, in the right side. So they are located in G7, G8, and G9. So these numbers here, 4, 12, and 18 in terms of hours, these are the other parameters. Okay, so I have shown you now, no, the two kinds of parameters, the coefficients 300 and 500 found in the objective function. And also, parameters are also these numbers 4, 12, and 18 found in the right side of these inequality symbols. In other models, this may not be less than or less than equal. It may also be greater than, or they may be equal signs. Okay. The point here is for you to identify the parameters. Okay, now that we have identified the parameters, the next thing is for you to understand when are these parameters sensitive? Okay, parameters are sensitive when a small change in the value of that parameter changes the optimal solution. Okay, let's illustrate that. How will it happen? Okay. um, parameters 300 and 500. Okay, let's just focus here, no, in these coefficients. If we will maintain here $500 and we will change $300, how do we change this 300? We can lower it or raise its value. To lower it, we can lessen it to, let's say, 200. Okay, and we want to see the effect of changing this. What's the effect on the optimal solution? Where's the optimal solution? Currently, the optimal solution is the combination of 2 doors and 6 windows. That's the current, no? When profit is 300 and 500 for windows. What happens if we change this? Okay, let's see. If we change the 300 to 200, what's the effect on the solution? And how do you do that? O sige, mamaya na how. What's the effect on the optimal solution? Is there a change? There's no change here. Okay. If we further change it to, now this time it was increased to 500. Earlier it was increased, there's no effect on the optimal solution. Now it's been increased to 500. Okay, what's the effect on the optimal solution? Is there any effect? There's no effect. No change occurs in the optimal solution. It's still the combination of 2 and 6. All right. And if that's the case of what? Changing this parameter did not change the optimal solution, then we will say that this parameter is not sensitive. It's not a sensitive parameter. Which one? The profit per door is said to be not a sensitive parameter. When is it sensitive? A parameter is sensitive, this one, if changing this a bit, like this one, no? If it changes, that changes the optimal solution, like it's no longer 2 and 6, but it became 3 and 5. Naging 3 and 5 to. And then, therefore, this parameter is sensitive. But it didn't happen. No? In this case, we changed this parameter a bit, and it did not change the optimal solution. So this profit per door is not a sensitive parameter. Okay, so I'll repeat that about the sensitive parameter. It says here, okay, again, a parameter is considered sensitive when a small change in its value changes the optimal solution. All right. Okay, so we're done with parameters, sensitive parameters. Now, what is the next concept to learn? The next concept to learn is how do you conduct a sensitivity analysis? Okay, the first step is select one parameter to change, one at a time. If you want to change this parameter, then do so, change it. Then make this 0, no? The optimal solution will now be changed into 0, 0, as because we don't have any solution yet. And we want to see what will be the optimal solution when we change this. So we changed this 300, as you see here, it was changed to 200. Then what do you do? We change this to 0, okay, as if there's no solution yet. We change parameter, then we make this units produce 0, turn them to 0, then run solver, okay? Then record what optimal solution came out. So you record it, okay? And then change this again, no, this parameter, change it again, let's say to 500. then make this solution 0, 0, then run solver. So every time you change this parameter, one at a time, no, change this parameter, record the optimal solution. Okay, it can be done manually, like what I am telling you now. No, you can do it manually, but you need to record the changes that has occurred. What changed? What did you change? And what's the effect on the optimal solution? And those changes are summarized on what we call the parameter analysis report. Okay, whether done manually or using Excel, you should have this report. Okay, so all of the changes on one parameter are herein recorded. The original value was $300 unit profit per door. No change done on the unit profit per window. We have the different values that were used to change the 300 or to replace the 300. Those are the different values. The least was $100 and the highest was $1,000. And look at the optimal solution. We have the combination of 2 doors and 6 windows, and they remain unchanged up to this point, no? When the parameter was changed to 700, up to that change, the optimal solution remains the same, no change. But beyond 700, let's say $800, you see that the optimal solution has changed into 4 and 3 combination. And within this range of other changes, 800, 900, 1000, the combination of optimal solution 4 and 3 remains the same, with these three values. And consequently, there will be changes in the total profit. No, whenever we change one parameter here. Okay, so naturally there will be changes in the total profit, but that's not the concern. The concern here is to what extent can we change one parameter like 300? When we changed it, up to what extent will this optimal solution remain the same, or when will it change? So actually the concern here is if changing one parameter and to what extent will it change the optimal solution. Yun yung concern natin, yung optimal solution. If the optimal solution will change, and what kind of change will cause that? No? What value of the parameter will cause the change? Ayan. So here, to answer my question, changing this parameter 300 to 800 changes the optimal solution. So the optimal of 2 and 6 are no longer optimal. The new optimal combination is 4 and 3, 4 doors and 3 windows. Now this report is further summarized in what we call sensitivity report to find the allowable range. So the focus here is the allowable range. Based on the parameter analysis report, Excel was able to establish the allowable range here. Okay, so we have the allowable increase and the allowable decrease. To explain this table, the final value here refers to the optimal values, no? The optimal solution. We have the combination of 2 doors and 6 windows. The objective coefficients, these are the parameters being changed. No, I showed you earlier. So we have the unit profit. The 300 here is the unit profit, and the 500 is also the unit profit, no, corresponding to doors and windows. For the doors, the allowable increase is only 450, and the allowable decrease is 300. It is by, no? Ibig sabihin, You can increase this 300 by 450 and still have the optimal solution of 2 and 6. But then you don't change them both, no? It will remain 500 for the Windows unit, no? Profit. But you change this 300 by 450, increase it. If you increase it by 450, so what will this number be? 300 plus 450, that will be 750, which means that if you change this 300 to 750, you will still have this optimal solution, the combination of 2 and 6. How about if we increase this 300 by 500, okay, what will be the effect? Well, 500 is already beyond 450. So if you will use 500, no, increase 300 by 500, this will be 800. If this becomes 800 with this remaining at 500, what will happen to the optimal solution? It will no longer be the same optimal values of 2 and 6. It will no longer be optimal at 2 and 6 because you have gone beyond the allowable increase. Okay? How about if we increase this by 350? What can you conclude? The 350 is still within the allowable, 'di ba? Kasi so if you change this to by adding 350, this will become 650. So if we change this to 650, what's the effect on the optimal solution? It will still be optimal because the increase is within the allowable. On the other hand, the allowable decrease is 300 by 300 yan. So if 300 minus 300, if 300 will decrease by 300, this will become 0. What happens to the optimal solution 2 and 6? It will still be the same. It's still optimal at 2 and 6 combination. Why? Because we did not violate the allowable decrease. But if we decrease this by 400, kahit not, let's say, if we decrease this value by 350, 350 is already exceeding, no, the allowable. 350 na. So, yung 300 minus 350, negative 50 na yan. Then, if with that change, what happens to this optimal value? No longer optimal. Naturally, it will change. Okay? Now, on the other hand here, if we maintain the 300 here and change this, apply changes here, we are limited, no, to change this value within this allowable increase and within this allowable decrease. If we will decrease 500 here by 300, it means 500 minus 300. This becomes 200. Okay, without changing that, no. If this is 200, what happens to the optimal solution here? It will still be the same. It will be still optimal at 2 and 6. Okay, but if we violate this one, no? If we decrease beyond 300, let's say, decrease natin, sige, by 350. Okay, so the 500 minus 350, that will be 150. So when this becomes 150 with this unchanged, what happens to the optimal solution? It will change. It will no longer be optimal at 2 and 6 because we have gone beyond the allowable decrease. How about we decrease it by 200? Is 200 within the allowable decrease? Of course, it's still within the allowable. Hindi ka naman lumampas sa 300. So, if the decrease is 200, 500 minus 200, that will be 300. So, if we change this with 300, the optimal solution of 2 and 6 will still be optimal. Okay, that's it, no? Changing only one parameter. Now, going back to our procedure here, I skipped some slides. Okay, the slides I skipped, it's about using Excel to generate the parameter analysis report. What I gave you earlier is the manual sensitivity analysis, no? By recording the results. But then Excel can do it for you. All you need is analytic solver. You have to have an analytic solver downloaded or activated on your laptop or computer. You need this analytic solver, but I don't have that, so I cannot demonstrate. I think you have to buy that, no, analytic solver. That's an application. Now, if you have this analytic solver, um, you can do the you can apply the steps here given, no, and these steps are also on your ebook. If you want to learn how to conduct sensitivity analysis using analytic solver, then you can do it. Now we have instructions here and in our ebook how to do it. So here we are being presented with when you click analytics using analytic solver, no? From analytic solver, when you click analytic solver, you click parameters, then you click optimization. And after clicking optimization, you should find this. And you should encode the lower limit. In our example, it was 100. No, that's the lower limit. You change the parameter, decreasing it to 100 and increasing that same parameter to a maximum of 1,000. So we have 100 lower limit and 1,000 for the upper limit. These are what we call the tawag mo dyan, the range. No, we have with the range of 100 to 1,000, the range within which to change one parameter. Okay? So i-input mo lang yung lower and upper limit. Then you will be able to, ayan, fill upan mo lang yung mga yan. Okay, yan. Choose optimization, the parameters menu. So may fill upan ka pa, no, other boxes to fill up, no, yan. Dito uh, yan. So may mga i-click ka dyan. Just follow the steps here, no, okay. But the point is, no, what I want you to learn is to how to interpret the parameter analysis report. That's all that I want you to do or to accomplish, no, just be able to interpret the parameter analysis report and what is its relevance to the changing one parameter. Okay, so changing one parameter leads us to this results, and also how to interpret or understand the sensitivity report for the allowable range. That's all that you need to accomplish, no, understanding these tables. Okay, we skip the graph. Okay, then so that's changing only one parameter. Okay, how about if we simultaneously change two parameters, no, like changing two coefficients in the objective function, like this one. Yeah, okay, here ano ba yung original value nito? Okay, so here we have, hindi pa yung simultaneous kasi 1,000 to, original naman ito is 500. Let's look for the simultaneous changes. Okay, here we're looking at simultaneous changes. Ito. The original value here was 300 and here it was 500. So if you increase one, you need to decrease the other one. When you here the unit profit per door was increased from 300 to 450, and the unit profit for the window was decreased from 500 to 400. So we call that, changing two parameters, we call it simultaneous changes in the objective coefficients. Okay. And there will be a different report generated. Okay. And as these changes were being conducted, no, as you apply changes at the same time on two parameters, yeah. Okay, let's look at the changes. Okay, 600 to 300. Kanina, 450 and 400. Ngayon, we have 600 and 300. Okay. Now, with these changes, the question is, what happens to the optimal solution? We also would want to find out what's the effect on the optimal solution. The effect on the optimal solution will be shown in the parameter analysis reports, but it's a two-way. It's called a two-way parameter analysis reports. And this is applicable when we change two parameters at the same time. Okay, yan yung simultaneously changing two parameters. Okay, sabay mong pinalitan yung dalawang parameters. All right. So, how do we use these two-way parameter analysis reports? First, we have the total profit table above. Then below, we have the optimal solution in two separate tables. The left side shows us how many doors will be produced in combination with how many windows produced on the right side. Okay. So let's have one combination. If we change 300, diba, in the original, unit profit per door of 300, if we change it to 600, okay, here, increase to 600, therefore we need to decrease unit profit per window. So from 600, we decrease the window profit to 100, okay. Where do they meet? So what will be the solution, optimal, okay? So from we have A6, cell A6. Okay, we have cell A6. Then they meet here. Ano tawag mo dyan? They intersect. Okay. 100, use 100, change unit profit per window 100, and change 300 to 600. Where do they intersect? At this point. So how many doors will be produced? Four units of doors will be produced. Okay, so the location is B6. So to learn how many windows to be produced, you also go to B6 in the other table. So we have B6 here. This is the windows to be produced, 3 units. So what's the combination? What's the optimal solution? 4 and 3. Okay. How about if we change the value simultaneously? Let's say 400 unit profit per door, increase yan. So decrease ka uli dito. So 200, no? Let's say combination of 200 and combination 200 for the window and 400 for the door. Where do they meet? Dito sila nag-meet. Okay? So there will be 4 doors produced. So this is at C4. So look at C4 here to determine units of windows produced. 3. There will be 3 windows in combination with 2 doors. So 2 and 3 are the combinations. Okay, that's C4. Okay. So to determine the total profit, puntahan mo rin yung C4 na yan. No? C4 sa taas. Column C, row 4. Okay, so we have $2,200 for the total profit, no? Which will result from the combination of for the 400 and 200. Unit profit for the window, 200, in combination with 400 unit profit per door. So there it is, no? Uh, how to interpret the two-way parameter analysis reports. Okay, what will happen now to the optimal solution? From the original, if you apply changes on the parameters, no, sabi natin, palitan natin 300, gawin natin 400, tapos yung 600, gawin natin 200. What will happen to the optimal solution? Will it still be the same? So, and we will find out, no, using the 100% rule. Okay, for when we simultaneously change the two parameters in the objective function, we will use the 100% rule to determine the effect on the optimal solution. Okay, so how do we use the 100% rule? We compute for the percentage changes. For our example, the profit per door was increased from 300 to 450. And the profit per window was decreased from 500 to 400. So calculate what's the change from 3 to 450. So subtract um, the smaller value from the larger value. So anong difference niya? 450 minus 300. Kahit dito makikita mo na. It's difference, no? From 300 to 450. There's been a change by 150. And in the profit per window, decreased it to 400. What's the change? What's the magnitude? You will get the difference between these two values. So that will be 500 minus 400. That will be 100. So here, meron kang 100 sa numerator. Dito naman, you have 150, no, in the numerator. Now, how do we get the divisor here? Where do we get this divisor? 450 and 300. 450 is the allowable increase indicated on the table. And 300 is the allowable decrease from the table now, based on the table. I'll show you that table. Let's look at the table again. The sensitivity, no? The sensitivity, saan ba yun? Table na yan. Saan yung table? The sensitivity report for allowable, yan. Okay? So we have 450 for the allowable increase and 300 for the allowable decrease. Okay? So yan yung ginamit dito as those numbers were used to be the divisors here. So 450 is the allowable increase and 300 is the allowable decrease. Now, the quotient is here in the percentage of allowable increase is hereby computed as 33 and 1/3%. And computed allowable percentage allowable decrease is 33 and 1/3%. Then the next is to sum up these two percentage changes. And in this case, we see we have 66 and 2/3%, no, as the sum of the percentage changes. We will evaluate this sum if it's within 100%. Then we go back to the 100% rule. It says, so how do we evaluate the 66%? It says here. The question is, will the solution be still optimal? Will still be optimal? Okay, this is the rule. If the percentage changes does not exceed 100%, okay, ito, did not exceed 100%, the original optimal solution definitely will still be optimal. Okay, so optimal pa rin yung solution. How about kung 100? If the sum of the percentage changes is 100%, like this one here. Okay, when we increase 300 to 525 and we decrease 500 to 350, what is the sum of those changes? It's 100%. So pasok pa rin sa 100. So optimal pa. The solution is still optimal. What now if the sum of the percentage changes is beyond 100%? It's 133 and 1/3% in this case. Okay, so how do you evaluate this? Will the solution still be optimal? We cannot be sure here. No, look at the rule. If the sum exceeds 100%, then we cannot be sure. We cannot be sure if the original optimal solution will still be optimal. It did not say it's no longer optimal. It only said we cannot be sure. Okay, that's it. Now okay, that's how to interpret no simultaneous changes in the objective functions. Now, changing two parameters in the objective functions. So we applied two kinds of changes. The first change is change only one parameter. Okay, you change only one parameter, then look what happens and see what happens to the optimal solution. And the report that we will need is called a parameter analysis report. No, changing only one parameter. And then for other values, we can use the sensitivity report for the allowable range to find out what happens to the optimal solution if we keep changing the parameter or one of the parameters. Okay, so we use these two tables. Now, if we will change two parameters at the same time, like this two, no, we change this simultaneously, we will need another report, no, to determine what happens to the optimal solution, what will be the optimal solution. Okay, we will use the two-way parameter analysis reports, which will be generated by Excel. And aside from this, no, to see whether the original optimal solution is still the same, we will use the 100% rule. But before you use the 100% rule, you have to compute for the percentage changes. Okay, and then sum up the percentage changes. And the sum of the percentage changes will be evaluated